Hello, welcome to day 2 of 5.3. Yesterday you learned the composite functions for sine and cosine, and today we're going to learn the composite function properties for tangent. Okay, so let's start off with tangent of a minus b. Okay, that means we need to recall a couple things. We have to remember our quotient rule that tells us that tangent is equal to sine theta over cosine theta. So if you look at this, you can right away see that tan of a minus b is going to be the same thing as sine of a minus b over cosine of a minus b. And then we have to remember our composite functions from yesterday. So if we have sine of a minus b, we know that's going to be sine of a cosine of b. Remember, sine stays the same, so it should still be minus, and then it's going to be cosine of a sine of b. And then we have to remember cosine of a minus b. So I'll write that back up. Cosine of a minus b is just, remember cosine does both cosines at the front, so cosine a, cosine b, and then it switches signs. So since this is minus, this is going to be plus. And so then I have sine a sine b. All right, so if we recall those properties, then the proof will be a little bit easier to follow. All right, so then we are going to apply those two composite properties and rewrite sine of a minus b as sine of a cosine of b minus cosine of a sine of b, divided by cosine of a cosine of b plus, so this was just the composite properties. Okay. Then what we're going to do is we're going to get a little creative, and we are going to divide everything by cosine a cosine b. So divide all four terms by cosine a cosine b. So you can see that guy got divided, that guy got divided, that one got divided here, that one got divided here. And so now we get to cancel things that look alike. So you can see cosine b and cosine b cross off, cosine a and cosine a cross off, cosine a and cosine a, as well as cosine b and cosine b. And over here, nothing crosses. All right, let's simplify this a little bit. Okay, so I just got rid of my crossing out so you can just see it a little cleaner. Everything crossed off here, so that just became a 1. Now we're going to use our quotient property and recall that sine of a over cosine of a is equal to tangent of a. And we know that sine of b over cosine of b is equal to tangent of b. And on the bottom here, the 1 carries, and we have sine of a over cosine of a, again is tangent of a, and sine of b over cosine of b is tangent of b. And so that brings up our first composite property for tangent. So tangent of a minus b. Make a couple thoughts here on this equation. So notice it's tan a, tan b, and the sign on top stayed the same. And then it's 1 plus tan a times tan b. Okay, so we got to take a look at those. All right, now let's do the same thing for tan a plus tan b. Okay, and we want to show that that's the property. Notice the sign on the top stayed the same. The bottom switched, so it was plus, now it's negative, but it looks pretty much identical to this guy here. Tan A minus tan B, 1 plus tan A tan B. And here we have tan A plus tan B, over 1 minus tan A, tan B. So really the only thing that's switching is the signs. So we're going to apply the exact same process that we did for the other function. If you want to give it a shot, stop the video and try to do it on your own. If you don't feel comfortable, then follow along. So I've got it sine of A plus B over cosine of A plus B. And then we apply our composite properties. So I'm going to write sine of A cosine of B. Sine stays the same sign, so it's plus. And then it switches, so it's cosine of A sine of B. And on bottom, cosine is cosine A cosine B, but the sign switches, so since it's plus, it's now minus sine A cosine. Sine A sine A B. All right, just like we did the next one, or the last one, we divide everything. We're going to do the same thing here. We're going to divide all by the cosine A cosine B. Okay, so if I do that, I'm going to have sine A cosine B. I'm just going to write this top again. And I'm going to take both of those terms and divide by cosine A cosine B. Take both of these terms, cosine A cosine B. Okay, the denominator was cosine A cosine B minus sine A sine B. And take each one of those terms and divide by cosine A cosine B. All right. And then we just start canceling stuff off. So cosine B's cancel off, cosine A's cancel off, cosine A and cosine B cancels, and here nothing cancels. Okay. Now we write it using our quotient property. So sine over cosine we know is tan. Sine B over cosine B is going to be tangent of B. If everything crossed off, we're left with a 1. And over here, sine A over cosine A is tan A. And sine B over cosine B is tan B. All right, so we proved the other composite property, tan A minus B. All right, a little bit of work there, but now we're going to apply all our properties that we know. Okay, so we are going to, these are the directions for the next few slides. Use the composite argument identity to rewrite the left side as one function, and then solve using the general solution and the particular solution. So this gets back to a couple chapters ago when we had to do the plus 360k and so forth. All right, so the first thing you have to do is you have to look at this left-hand side here and see, okay, is that a cosine composite or a sine? And since it goes sine, cosine, then we know it's sine. And then because of the plus sign, this had to be A, this is B, and so this is sine of A plus B. All right, so you can rewrite sine A cosine 25 using the property, and I'll just write the property up here so you're used to it. So sine of A cosine of B plus cosine of A sine of B. And we know that equals sine of A plus B. That's our composite property. So you can identify then, okay, that looks identical, except A is theta and B is 25. And so we just replace A with theta and B with 25, and we know it's equal to the square root of 3 over 2. All right, that's the only new part. Now we do all the old stuff that we've done for a few chapters. So we have to solve for theta, so we have to get rid of sine. So that means we take inverse sine of both sides, And we're back to those beautiful exact values. And so I ask you, what is inverse sine of root 3 over 2? Hopefully you tell me my answer is 60 degrees plus 360, but also don't forget it is 180 minus 60 plus 360 degrees. All right, remember there are two quadrants where sine is positive. All right, so you're going to be looking here at the 60-degree angle, or you're going to be looking at your 120-degree angle, which is the same thing as 180 minus 60. So now I have theta plus 25 equals 60 plus 360k. And I have theta plus 25 equals 120 plus 360k. All right, next step we do is we just subtract the 25 from both sides. And if I subtract 25, I can't move it from the 360, only from the 60. And that's going to leave me with 35 plus 360k, and that is our general solution. And over here, we subtract the 25, and we are going to be left with 95 plus 360k. General solution. If they want particulars, my guess is they want them from 0 to 360, so there is 35 for an answer here and 95 for an answer here. If you add 360 to either one of those numbers, they're clearly going to be over 360. All right, let's try another one. If you feel like that's a good enough example, try this one on your own. Try to identify the composite property and then see if you got it right. All right, so I can tell since it's cosine and cosine that it's going to be the cosine A, cosine B. The sign is minus, so sine A, sine B. And since cosine switches signs, I know that's the same thing as cosine of A plus B. So in this case, A is 4x, and B is 2x. And so you can write that whole left side as cosine of 4x plus 2x, which is the same thing as cosine of 6x. All right, that's the only thing new. Apply all the rules you've learned in the past. So you figure out inverse cosine of 1, right? Wherever you do plus or minus, and you add the 360k. So hopefully you're saying to yourself, cosine is x. X is 1 when theta is 0, so this is plus or minus 0 plus 360k. And then we divide everything by 6. And we have x equals plus or minus 0 plus 60k. And so that is our general solution. And our values then would be 0, 60, 120, 180, 240, and 300. So I just keep adding 60, right? 0 or negative 0 doesn't make sense, so really you don't have to worry about the negative part. So your generals, or those are your particulars.